Welcome to Infinite Universe with interesting episode. Make sure every drop of oil goes exactly where it's needed without waste. These small changes add up. By reducing friction, Toyota ensures that more of the engine's power actually reaches the wheels instead of being lost inside the system. It also means the engine runs cooler, lasts longer, and needs fewer repairs over time. That's part of Toyota's strategy, building engines that aren't just powerful or efficient, but also extremely durable, especially in places where extreme weather or poor fuel quality can cause early damage to less robust designs. This level of engineering detail is part of why Toyota feels so confident in calling the dynamic force engines game-changing. While competitors race toward full electrification, Toyota is refining and optimizing combustion technology to meet the needs of millions of drivers today and tomorrow. For Toyota, this isn't a matter of avoiding electric vehicles. It's a matter of providing the best solution for every type of driver in every part of the world. In places where electricity is expensive, unreliable, or generated through fossil fuels, a well-designed combustion engine might actually be the greener choice. And in these cases, the dynamic force engines are Toyota's best shot at keeping combustion relevant for years to come. This global view is critical. Toyota isn't thinking only about cities with thousands of EV chargers. It's looking at rural roads in Africa, mountainous regions in South America, freezing winters in Northern Europe, and high-heat deserts in the Middle East. In these environments, vehicles still need to perform reliably, and gasoline or ethanol engines are often the only realistic option. The dynamic force engines, with their flexibility, efficiency, and resilience, are a practical answer to a very real problem. Another key advantage is how seamlessly these engines integrate with Toyota's hybrid technology. The fact that the same engine design can be used in both regular fuel cars and hybrids gives Toyota unmatched flexibility. They can offer a range of vehicles, from fully gasoline-powered to advanced hybrids, without the high cost of designing completely different engines for each one. This allows Toyota to adapt quickly to changing regulations, customer demands, and fuel availability, while still maintaining strong performance across their lineup. Even more interesting is Toyota's ongoing research into alternative fuels. Unlike most manufacturers who are focused only on electricity, Toyota is exploring how dynamic force engines can run on ethanol and even hydrogen. Ethanol, especially in places like Brazil, is widely available and renewable. Hydrogen, while still in its early stages, offers a future path to zero emissions without relying entirely on batteries. Toyota has already demonstrated prototypes of hydrogen-powered combustion engines, and the dynamic force platform is helping make that possible. With the TNGA architecture as the foundation, Toyota can update its engines, test new fuels, and apply new technologies faster than ever before. This modular design saves money, reduces waste, and shortens the time it takes to get a new idea from the drawing board to the dealership lot. It also means Toyota doesn't have to bet everything on a single technology. If the market shifts toward hydrogen, they're ready. If ethanol gains traction, they're covered. And if hybrids remain the dominant choice in many regions, the dynamic force engines are already optimized for that as well. From a business perspective, this gives Toyota a major advantage over its rivals. Companies betting entirely on EVs are investing billions in battery technology, mining, and charging networks. That's a risky move, especially if those systems face delays, costs rise, or customer interest grows slower than expected. Toyota's more balanced approach, improving combustion while expanding electric options, gives it the ability to serve a broader range of customers without overcommitting to one uncertain path. Performance also matters. For all the talk about fuel savings and emissions, drivers still want vehicles that are fun to drive. The dynamic force engines don't sacrifice responsiveness or acceleration. In fact, many drivers report smoother power delivery, quicker throttle response, and quieter engine operation in Toyota models using these engines. These are not loud, clunky, or outdated machines. They feel modern and refined, giving everyday drivers a sense of confidence and control whether they're commuting in traffic or driving long distances. Even in racing, Toyota has begun applying the principles behind the dynamic force engines. Their motorsport division is testing how high thermal efficiency and alternative fuels can be used to make racing cleaner without losing the excitement. This trickle-down approach, where innovations from racing influence consumer cars, has been a Toyota hallmark for decades, and the dynamic force engines continue that tradition. It's easy to see why Toyota's CEO spoke with such boldness. For a company known for quiet, steady progress, this declaration marks a change in tone. Toyota isn't just responding to the EV revolution, it's offering its own vision of the future, one where internal combustion still has a role, but in a smarter, cleaner, and more adaptable form. In the face of intense global competition, that kind of confidence doesn't come lightly. It comes from decades of engineering, deep understanding of global markets, and a belief that the future of mobility will be more than just one thing. As the automotive world rushes toward electric dreams, Toyota is reminding everyone that innovation doesn't only happen in batteries and wires. Sometimes, it's in the details, in the precise shape of a combustion chamber, in the harmony between a piston and a spark, in the quiet hum of an engine that wastes less and gives more. The dynamic force engines aren't just a technical achievement. They're a strategic statement. Toyota will not be left behind. It will lead not by abandoning the past, but by reinventing it. Toyota has developed the dynamic force engine to meet the strict global emission standards that are becoming more common. These engines are made to reduce emissions right from the beginning. They use oxygen sensors that respond quickly and special catalytic converters that allow exhaust to pass through easily. The catalytic converter is also placed closer to the engine so it can heat up faster. This helps it work more efficiently as soon as the engine starts. In hybrid versions of cars, the engine can even turn off during moments when the car doesn't need much power. During these times, the electric motor takes over. When the engine starts again, it does so quietly and produces fewer emissions. This is where the connection between TNGA, Toyota New Global Architecture, and the dynamic force engine becomes important. TNGA is designed to support both gasoline and hybrid power systems, and the engine's software is designed to move between them smoothly. Although gasoline is still the main type of fuel used in most vehicles, Toyota built the dynamic force engine to work with other fuels too. In some parts of the world, ethanol is used more often. In other places, fuel rules might require engines to run on low-sulfur fuel or other fuel blends. Toyota tested the dynamic force engines with ethanol blends and confirmed that they are compatible with flex fuel systems. That means they can run on a mix of gasoline and ethanol without any problems. Toyota is also looking into using hydrogen as a fuel for combustion engines. This is different from hydrogen fuel cell vehicles. In hydrogen combustion engines, hydrogen is burned inside the engine just like gasoline. But instead of harmful gases, the result is mostly water vapor. One of Toyota's test vehicles using this method is the GR Corolla H2, which is still in development. This shows how flexible the dynamic force engine system is and how it's being prepared for the future. The dynamic force engine is also a big part of Toyota's TNGA platform. TNGA has not only improved how Toyota vehicles look and feel but also made it easier for the company to use new types of power systems. TNGA was created to support the dynamic force engine family from the very beginning. This means Toyota can easily change the engine size or type without having to redesign the entire vehicle. This flexibility helps Toyota save time, reduce costs, and provide a consistent driving experience all over the world. Whether someone is buying a Camry in the US, a RAV4 in Europe, or a Corolla in Asia, the engines in these cars share the same technology, refined, efficient, and built for the future. Some of the first cars to get the dynamic force engines were Toyota's best-selling models, the Camry, RAV4, and Highlander. These cars were also early users of the TNGA platform, making them ideal for the new engines. For example, the Camry uses the A25A FKS, which is a 2.5-litre inline-4 engine that produces around 203 horsepower. It's paired with an 8-speed automatic transmission. The hybrid version of the Camry uses the same engine with an electric motor. This setup gives it up to 208 horsepower and excellent fuel efficiency, up to 50 miles per gallon. That's better than rivals like the Honda Accord Hybrid and the Hyundai Sonata Hybrid. The RAV4 also uses the A25A series in both its standard and hybrid versions. For a compact SUV, The dynamic force engine gives the RAV4 good acceleration and great fuel economy. The hybrid version of the RAV4 has become the top-selling hybrid SUV in North America. It delivers over 40 miles per gallon while still being practical and reliable. This success proved that Toyota could use the new engine technology across different types of vehicles. In the larger Highlander SUV, Toyota replaced its older V6 hybrid system with a 2.5-liter dynamic force engine in hybrid versions. Even though the engine is smaller, the new hybrid system produces 243 horsepower and gets up to 36 miles per gallon. It also meets the latest emission standards in both the United States and Europe. After seeing how well the new engines performed in mid-size cars and SUVs, Toyota started adding dynamic force engines to smaller cars like the Corolla. The Corolla is one of Toyota's most important vehicles, with over 50 million units sold around the world. In its 12th generation, the Corolla uses the M20AF-KS for non-hybrid models and the M20AF-XS for hybrids. The hybrid version of the Corolla, which was already popular in Japan and Europe, quickly became a hit in the US and Australia. It offers over 50 miles per gallon with little to no compromise on performance. Customers have praised it for smoother engine operation, better throttle response, and seamless transitions between electric and gasoline power. In smaller markets like Japan and parts of Europe, even smaller engines are used. The 1.5-liter M15AF-KS and its hybrid version, the M15AF-XE, are used in the Yaris and Yaris Cross. These engines are small but efficient. Thanks to the lightweight TNGAB platform, these cars are easy to drive, fuel efficient, and meet local emission rules. In cities like Tokyo, Paris, and London, these models are popular for their low fuel use and emissions. In hybrid versions, they can even get more than 60 miles per gallon. The CHR, a subcompact crossover, also uses dynamic force engines. It's especially popular in Europe, where hybrid models enjoy tax benefits due to low emissions. The CHR offers both 1.8-liter and 2.0-liter hybrid versions, which strike a good balance between performance and fuel efficiency, all within a modern, stylish package. Toyota has also adjusted the dynamic force engine family to match local needs in different regions. In places like Brazil and India, where ethanol-blended fuels are used more often, Toyota offers flex fuel versions that can run on E85 and similar blends without hurting the engine's durability. In North America and the Middle East, where people still prefer larger SUVs and trucks, Toyota pairs dynamic force engines with traditional V6 or even V8 engines. But this is beginning to change. The Tundra pickup truck now comes with a hybrid system that includes a 3.5-liter twin-turbo V6 and electric motors. This is part of Toyota's iForce Max strategy, which was inspired by dynamic force technology. In China, where the government is pushing for cleaner vehicles, Toyota has worked with local companies to launch hybrid models using the 2.0-liter dynamic force engine. These cars are classified as low-emission vehicles and are eligible for government incentives. As fuel prices rise, more people in China are buying hybrids, and Toyota is increasing its efforts in this area. The dynamic force engine is not just for everyday cars. Lexus, Toyota's luxury brand, is also using this new engine technology. The Lexus ES250 uses the 2.5-liter A25AF-KS engine, while the hybrid ES300H uses the A25AF-XS. Other Lexus models like the UX, NX, and RX hybrids all use some version of the dynamic force engine. These luxury hybrids show that a high-efficiency engine can still offer strong performance and a smooth, comfortable driving experience. When paired with Toyota's electric drive modules and electronic continuously variable transmissions, ECVTs, the result is luxury without high emissions. Toyota's new Crown, which combines elements of a sedan and an SUV, also uses a dynamic force-based hybrid system. It comes with all-wheel drive and high-performance electric motors, offering both fuel savings and a fun driving experience. This model reflects Toyota's goal to blend style, function, and efficiency into one vehicle. So far, customer feedback has been very positive. Drivers have noticed smoother power delivery, quieter engines, and better gas mileage. Repair records show no major problems, which is a big success considering how widely the engines are used. Dealers say customer satisfaction is high, especially among hybrid buyers. Toyota made a smart move by keeping hybrid cars affordable while improving how far they can go on a single tank and how well they drive. These improvements attract not only environmentally focused customers but also people who just want to save money without giving up performance. Toyota continues to lead in fuel economy tests from both the EPA and WLTP, especially for non-plug-in hybrids. Emissions have dropped across the lineup, helping Toyota meet tough regulations in Europe, Japan, and California. While many car companies are moving quickly toward fully electric vehicles, the real question is whether gas engines can evolve fast enough to remain useful. Toyota believes they can, and the dynamic force engine is the company's answer. Instead of getting rid of gas engines entirely, Toyota is making them better. The goal now is to create engines that work smarter, are cleaner, and operate more efficiently, especially when teamed up with electric motors. The dynamic force engine is no longer just a regular engine. It's now a major part of Toyota's bigger plan for electrification. The goal isn't just to save fuel anymore. It's to build a smart system where all parts of the car work together. Toyota engineers have said clearly that if gas engines are going to stay useful, they must improve quickly. The current dynamic force engines like the A25A FXS and M20A FXS already reach thermal efficiency levels of 41 to 43% in hybrid setups. That's impressive, but Toyota wants to go even further, to above 45%. To reach this, engineers are working on better combustion, lower friction, and more advanced valve and intake systems. Toyota is also testing new ideas like engines with adjustable compression ratios, smarter thermal management, and low-temperature exhaust gas recirculation. These changes are designed to get more energy out of less fuel and with fewer emissions. These improvements are not just about saving money, they're about staying ahead in a world where hybrids might compete with full electric vehicles. Toyota's success with hybrids has always come from how well their gas engines and electric motors work together. The next generation of Toyota hybrids will have even more powerful electric motors, better batteries, and engines that are designed to be efficient in specific situations. For example, the engine might stay off in cities and only turn on during highway driving. This kind of setup is already being used in Toyota's plug-in hybrids and is coming to regular hybrids too. Toyota is also looking into using 2 electric motors, one for each axle, along with a dynamic force engine. This setup would offer all-wheel drive and better control without needing a mechanical connection between the front and back. That could lead to better performance and safety in a wider range of vehicles, from small cars to big SUVs. Toyota also knows that not every country will be ready to fully switch to electric vehicles right away. That's why they're preparing their dynamic force engines to work with a variety of future fuels, including hydrogen, biofuels, and synthetic fuels. These options will allow Toyota to continue offering low-emission vehicles even in places without widespread electric charging infrastructure. The story of the dynamic force engine is still being written, but it already shows how gas engines can have a future in a changing world. Thanks for watching. Keep it and stay tuned for interesting episodes onwards. Like and subscribe our channel. Have a good day.